Have you ever wondered why a hot coffee cools down, why stars eventually burn out, or why your computer heats up when processing data? Behind all of these questions lies one of the most powerful and universal frameworks in science, thermodynamics and statistical physics. Welcome to the Learning Studio, and in today's episode from our physics playlist, we'll explore how thermodynamics and statistical physics explain not just heat and energy, but the very flow of reality itself. You can watch the complete physics playlist by clicking the link below in the description. This topic is part of our section Foundations, the Universe, Matter and Energy, the 12th subject in our animated educational series, where we transform complex science into clear, visual, and meaningful stories. The story of energy. Every process in the universe, from the motion of galaxies to the firing of neurons in your brain, involves energy. Thermodynamics is the branch of physics that studies how energy moves, transforms, and interacts with matter. It's built on four fundamental laws, often called the laws of nature's bookkeeping system. The zeroth law defines temperature and establishes thermal equilibrium. If two objects are each in equilibrium with a third, they're in equilibrium with each other. The first law, energy cannot be created or destroyed, only converted from one form to another. The second law, in every process, disorder, or entropy, tends to increase. This is why time seems to move forward, not backward. The third law, as temperature approaches absolute zero, the motion of particles slows toward complete stillness. These simple rules govern everything, from engines and refrigerators to black holes and stars. Entropy, the arrow of time. The second law of thermodynamics introduces one of the most profound ideas in physics, entropy. Entropy measures disorder, randomness, or the number of ways a system can be arranged. Think of it like this: a tidy room represents low entropy, a messy room, high entropy. Left alone, the room naturally tends to get messier, never spontaneously cleaner. The same is true for the universe. Energy spreads out. Order turns into chaos. This flow gives us the arrow of time, the reason we remember the past but not the future. Entropy is the universe's one-way ticket toward equilibrium, a silent principle guiding everything from thermonuclear reactions in stars to the melting of an ice cube in your hand. Statistical physics, the microscopic view. While thermodynamics deals with large systems, like engines or planets, statistical physics zooms into the microscopic level. It connects the motion of billions of atoms to the macroscopic laws we observe. The idea is simple but powerful: even if we can't track every atom individually, we can predict their collective behavior using probability and statistics. This approach, pioneered by Ludwig Boltzmann and James Clerk Maxwell, introduced the concept of the Boltzmann distribution, a mathematical tool describing how particles distribute energy. This same idea inspired one of the earliest machine learning models, the Boltzmann machine, an AI algorithm that learns by minimizing energy in a network, much like physical systems do when they reach equilibrium. So the next time you train an AI model, remember, it's learning like the universe itself, moving toward lower energy and higher stability. Thermodynamics in the universe and technology. Thermodynamics doesn't just explain heat, it describes the evolution of the cosmos. Stars shine by converting nuclear energy into light and heat. Black holes radiate energy through Hawking radiation. Even the fate of the universe, its slow drift toward maximum entropy, is a thermodynamic story. On Earth, these same laws power everything we build. Engines convert heat to motion. Batteries store chemical energy. Data centers rely on cooling to manage heat produced by computation. From cosmic scales to microchips, thermodynamics governs the balance between energy, matter, and information. The beauty of order in disorder. Thermodynamics and statistical physics teach us that even in apparent chaos, There is deep structure, a mathematical order behind disorder itself. They show that time, temperature, and life's very existence arise from the natural tendency of energy to spread out. It's not just a law of physics, it's the rhythm of existence. Every moment, every transformation, every heartbeat is a dance between order and entropy. This is the Learning Studio, and this was our episode on thermodynamics and statistical physics. If you enjoyed this journey into the laws that drive both the universe and modern technology, make sure to subscribe, like, and explore our physics playlist linked below. In our next episode, we'll explore how invisible fields and waves combine to shape reality itself, electromagnetism and Maxwell's equations. Because in physics, every law of nature is not just an equation, it's a story of how the universe keeps itself alive.